Howdy, everybody. Thanks for coming this morning. Title of this talk is Introducing Switch, a framework for custom data applications. Do it? Oh, right, got turned on. We're going to talk about building tools to make better decisions with data. As I said before, and you've heard many times, I'm Josh. That's a picture of me with my normal hat on. I've been obsessed with building data tools for about 20 years. You can find me as B² basically everywhere. I work at a company called Mode, which you can find at mode.com. We build a collaborative data science platform for our users who are data scientists, data analysts, and data engineers, whose job it is to help everybody make better decisions with data. So we're here to talk about data applications, and specifically we're going to talk about custom data applications. So what is a custom data application? Well, imagine all the things that you have to do in your business, all the business operations that you have to undertake every day, all of those things that you have to make decisions about with data. We've sorted these on the x-axis, if you will imagine here. All the industry standard operations of your business we put down on the left-hand side, all the domain-specific stuff on the right-hand side. On the left-hand side, say you're an e-commerce company, these are all the things that every e-commerce company has to do, right? Or every technical e-commerce company has to do. If we look at the level of off-the-shelf tool support for those things, it's very high because there's a lot of businesses for it, so there's a big market for it. On the other end, we have things that are very specific to our business. So if you're Amazon and your differentiator is, we get things to your house faster than anybody else in the world, that's gonna be down on this side. This creates kind of a long tail where there's not a lot of vendors, and most of the tools that you have to build to really execute these differentiated things, you have to build internally on your own, right? But this is why your business exists, right? This is the value that you're providing to the market above and beyond just kind of the standard stuff that you and all your other competitors do. So this is kind of the key premise of custom data apps, which is there's no collection of off-the-shelf tools that will provide everything that our organization needs to make better decisions with data across the board. Okay, so that's kind of the motivation for custom data apps. So the premise is this is actually where we should focus. So data teams should be spending most of their time building these kinds of applications rather than just wrangling data or trying to get the right data set. This is where the real value comes from. This is the reason that we have data in the first place. So we should spend most of our time as data teams building apps that deliver differentiated value for our business and not just kind of on the data itself. So in the example of the e-commerce company, this would mean something like a logistics tracking and monitoring tool that was laid out in a custom way and had custom metrics and was designed in a way that was specific to our business. If you're in, say, a B2B SaaS business and you're really dedicated to success, it can mean things like customer health monitoring tools for your success team. If you're in a sort of consumer app company and virality is really important to you, then an A/B testing tool might be an area where you invest in customization. I'm sure that most of you either work with tools or have worked with tools or presumably building tools that fit into this category. So sort of more concretely, here's an example of what one of these tools might look like. This example happens to be a custom customer analytics portal that you might actually deliver externally. A lot of the apps I was talking about were internal, but they also cover external stuff as well. And if you want to go deeper, this is the kind of application you might eventually want to deliver in sort of these custom scenarios where you're not just giving people sort of static content, you're letting them dig in, you're letting them explore, expose new things, look at things in new ways, right? So today, every single one of these applications is one-off. So when I was the director of data services at Yammer, we had not only to manage our data warehouse, data infrastructure, data stack, all that stuff, we also had to build an entire host of these tools for engineering, support, success, sales, like I said. There's no common standard way to build this stuff today. And so the result is a bunch of ad hoc, one-off code, different data processors, visualizations, different stacks everywhere. So this is a problem, obviously, because it's very expensive, it's time-consuming to maintain, it's really error-prone, which is particularly bad in the case of data apps because people use these to make critical decisions every day. And so Switch is a collection of TypeScript libraries and tools that let us build richer and more interactive data apps like the ones that I've been talking about. So it aims to be the data layer between the database and the user interface. So it's not a user interface library, and it's not trying to be a database. It's trying to be a library that bridges that gap and connects those things and brings them closer together, okay? So it lets us address some of the major challenges that we face when we're trying to build these kinds of applications. So we're going to talk about 3 of those today and about the tools that Switch provides to address those 3 things. All right, right into it. Challenge number 1. Our users always want to slice and dice their data in ways that we don't anticipate. I don't suspect this is a particularly controversial statement in this room. We don't always know what we're going to need ahead of time, and we don't always know the ways in which users are going to need to see it. And this is kind of the crux of this challenge, which is we can't build a new ETL pipeline or deploy our app every time we need to answer a slightly different question. It's too slow, and it's too expensive, and it also, the cycle time between the data team and the business users and the people in the organization is too long. What we should do instead is give our users the tools they need to quickly and easily express data in new and different ways on their own. So for that, Switch provides a system that we call formulas. So formulas, pretty basic. They're an Excel-like language for data expression. So if you think of Excel formulas, that's a pretty good analogy. They let our users build custom calculations, even if they're not database or programming language experts. What can we do with them? So one difference between formulas that Switch provides and Excel formulas is Excel formulas kind of work in this kind of willy-nilly world of cells, and Switch formulas work on data sets at a time, right? So we think of columns or attributes in data sets. So for these examples, I've used, again, this e-commerce data set. Hopefully it's pretty self-explanatory. There's a date, product name, things like that. So some of the things users can do with this. Well, let's say we've only given them price or quantity, and what they need to see is the ratio. Super popular. Ask any user, they'll tell you this. Calculate ratios, convert units. Oftentimes, we don't have things in the units we need. Clean data, oftentimes, even if you've built a perfect tool, the data comes in later down the line and it's not clean. This is a way to kind of clean it up in an ad hoc way. Aggregate data with aggregate functions, average sum, so on and so forth. Do it. And analytic functions for looking up values, scanning through windows of things. So what else can it do? So let's look at the sort of individual pieces. I'm kind of going to move through these quick. These are just the pieces of the language, so you gotta kind of get a full view of it. We have null values, okay? We have Boolean true false values. We have numbers, positive, negative numbers, hexadecimal numbers, if you're into that. We have single and double quoted strings for convenience. We have date literals with these hashtag symbols. We have regular expressions, again, if you're into that sort of thing, for string matching. Data access uses a square bracket, so if you want to access a column of data in your data set, use square brackets. Why? Mathematical operators, as you would expect. Relational operators for comparing values, kind of standard. Logical operators for Boolean logic. Case statements for comparing values. We have 4 kinds of functions. Constant functions, which give you the same value across the entire data set. Scalar functions for giving you one value per row on the data set, things like strings, numbers, date stuff. Aggregate functions, pretty self-explanatory. And analytic functions, like I mentioned, sometimes called window functions, for calculating across windows or frames of values in your data set. That's it. That's kind of the entire language. So it's simple, but the pieces can be recombined in a lot of ways, and it makes it really powerful. It means that we can build interfaces that let users extend our applications with their own business logic and calculations. For example, at Mode, we're working on a formula editor that lets our users add these custom calculations to their visualization system. A single formula that takes someone a few minutes to write might take hours or days to implement otherwise if you're going to have to go back to the source data and recompute it and build out a new pipeline, right? So not having to build ETL pipelines or write app code every time we want to answer a different question amplifies our effort 100x. That's my proposal, that you're saving 100x in cycle time and effort by exposing a system like this to your business users. We think that's pretty rad. I hope you do too. So to see how we might use those, let's keep going and talk about queries. So challenge number 2, when we build these apps, is getting from data to visualization. So a common characteristic of all custom data apps is custom data visualization, pretty much across the board. So we don't want to write ad hoc transformation code every time we want to build a new visualization. This is particularly error-prone and also very difficult. What we should do instead is use a language that lets us describe the data we need in a way that matches the visualizations that we're trying to deliver in our applications, right? We want to decrease the distance between these two things to make it easier and faster for us to build these visualizations. So with that, we're going to introduce queries. This is the second major part of the framework. Our queries are unique in the fact that they speak the language of data visualization natively. So the grammar of graphics is this language, and our queries are based on it. You can see here we've taken this picture from Vega Lite. It's a system, a rendering system, a UI system based on the grammar of graphics, and you can see how powerful the kinds of things you can make with that are. Most of the visualizations that we can encode with tools like Vega Lite can be translated directly into switch queries, like with very minimal changes. So how do they work? So there's two parts. There's a part where you define the data you want to see, and then the part where you map that data into the shape of the visualization that you need. So we'll talk about the data portion first. The atomic unit of data in a query is called a field. A field is simply a formula. Looks just like the ones we just saw in the previous section. They let us describe the data and calculations that we want to get back in our query results. This code on the right is just kind of like a pseudocode structure of what these objects look like. Like I said, they're the atomic unit of data. These are some examples again. They sort of define individual fields that you might use in different parts of your visualization. So there's two predefined fields that I'm going to use in some examples, so I want to point them out. They're called names and values. They let us combine multiple aggregate fields together into a single field. Don't worry if it doesn't make too much sense. We're going to have some examples, like I said. Hopefully that'll help you kind of see how those are useful. We've got filters. Again, they just let us get rid of data we don't want by adding conditions, pretty self-explanatory. We have sorts, also hopefully explanatory. They let us rearrange our data by adding ordering to our fields. So once we have fields, sorts, and filters, we want to map that to our visualization. So the way we do that is we use a structure called a mark. Okay, so marks are how we describe layers of our visualization. So one layer equals one mark data structure. Okay, so every layer is defined by a single field, which I've highlighted here. And they have these things called channels, which represent aspects of your visualization. So color, size, label, you can map a list of fields into these channels. And there's no predefined set. Switch doesn't predefine or specify any particular set of channels. So you can sort of use this as a domain-specific language to map channels that make sense for your visualization. So all together now, we use marks and all the other pieces we talked about to build the final visual mapping. And the mapping itself is what we call the pivot query. So we have marks, filters, and sorts, as I said before. We have some more channels up top. We have column and row, which lets you facet data across and down the visualization. If you think about trellis charts or small multiples, these are the types of mappings you'd use for those. And we have X and Y, which are generally header or axes fields, but sort of more academically, they let you position data within your facets. So values, again, they let us combine multiple aggregate fields into a single field that we can use in other places. All right, this thinking emoji, that's my signal that we're about to have an example. So let's start with this beautiful chart, two-series chart, pretty basic. We want to have a basic example here so we don't get too in the weeds. A beautiful chart deserves a beautiful query. Here's a beautiful query. We're going to run through it really fast. Hopefully it makes some sense. So here we have a formula, date trunc day on the x-axis, map to x. Do it for me, y. All right, we have our values field, which is that special field I was mentioning, mapped to our y-axis. We want to see that drawn on the y-axis. We have values. So these are the two fields that actually are being represented by that values formula. We have sum and running sum of quantity. We have one layer. Within that layer, we define it with the values field. And we want two series in that layer, each one to have the name of the actual formula that line represents. So here they are side by side. Hopefully you can kind of see the mapping. There's a little bit of a mental hurdle here if you're not used to speaking this language, if it's not like second nature to you. But I want to promise that over time it becomes second nature. And that once it becomes second nature, our ability to quickly transform and visualize data is increased by 10x. This one's a little less drastic, only in order of magnitude for this one, but this is a big improvement in how we build these applications. So challenge number 3. This one's the really important one, I think. We've kind of been building up to this one. So our data sets are millions and billions of rows and growing. This is a problem we all have. We can't constantly move it around or try to materialize everything we need because it's too expensive, and we don't actually know ahead of time what we might need. So what we should do instead is we should work with data as it exists in the places where it already lives. To do that, we introduce a concept called processors, which is the third big piece of the framework. So processors are the secret sauce to the whole thing, and so we're going to go into some detail about how they work. This is the important part about processors. They make it possible for our data apps to take advantage of the high performance and massive scale of the databases that we already have deployed in our organizations. They're what we call our databases analytical copilots, which hopefully you'll see why when we go through these examples. What do we mean by that? Well, let's talk about how a processor works, sort of at a technical level, and dig in to see how they take our database and sort of deliver stuff back out to our app. So at a high level, you can think of a processor as 4 stages. First step is they take the query that we just saw from the previous step. They plan the query, so they build a set of instructions for processing to get to the final result. The plan moves to the execution phase where our processor executes the plan. As part of that execution, though, we'll actually run queries against our underlying relational database. We'll actually push things down into that layer. We'll bring that back up to the processor. We'll do some post-processing there, and we'll return our final result to our application where it can build it into a data component or a visualization or what have you. So we're going to look at the planner first. That's the first step. And arguably one of the most important. So the planner looks at our query, the query that we just saw, in a specific order, and it builds a plan of what to do. So we're going to go through the order that it actually plans in. So first, we look at all the fields that we saw in the query. We add those to the plan. Next, if we have any of those special names and values fields, we add those to the plan. We look at filters, add those. Then we look at sorts. Then we have limits and offsets, which we didn't see, but can also be included in queries. And this is the important part. As we go through each step of the planner in order, it decides which part of the query that we want to process in the database and which part we want to process on the client. So the client here doesn't necessarily mean like a mobile device or a browser, although it can. The client can also be this post-processing code that's actually running on the server. In fact, that's how we have it deployed at Node today. So how does it decide what to do in the database and what to do on the client side? Well, it has a pretty simple rule, which is the planner always decides to push down grouping and aggregate expressions and always pull up analytical expressions. And we're going to go through an example of that. Thinking emoji. Example. So let's say we send a query in and it has this field in it, 1 plus running sum, and within that the sum of the price plus 1. So sum of price plus 1 is what we call an aggregate expression. So aggregate expressions are just any aggregate function, and then any of the operators kind of attached to those. So in this case, it's the plus 1 part also. This front part here is called an analytic expression. Very, very similarly, an analytic expression is any analytic function and all the operators attached to it. So in this case, it's the running average and the plus 1 attached to it. So the planner will split this into 2 parts. It'll take the aggregate part, sum of price plus 1. It'll add that to a query that it's going to send to the database and alias it. And then the second part is the 1 plus running sum part, which it will leave to process on the client side. So whenever we push down expressions, we always give them unique aliases, and those are the things we use to reference them later on when we're doing processing on the client side. So that's how these two things kind of get matched up. It's like the link between worlds there. I know what you might be thinking. This probably seems like a lot of trouble. Why don't we do everything in the database? Well, the main reason is portability. So our organizations operate dozens of databases across almost as many vendors, as I'm sure most of you know. One of the design considerations for the framework was that we wanted a common data processing model that we can rely on across the entire organization for every internal app we build. Most organizations end up building dozens and dozens of these custom internal data apps as they scale, and we want this to be able to scale across all of those. So we take a lowest common denominator approach, which means as long as our databases can do basic stuff like select, group, aggregate, filter, and sort, we can handle the rest, right? So almost every database, every streaming system, every big data system can do these operations, and so we can deploy the processor on top of those, any of those underlying databases. All right, last part, we're actually going to talk about the execution step. So after the planner, the execution happens, and so we kind of want to walk through that to see an example of this. So the very first thing that the executor has to do is make a query to your database to get data. There's no data. There's not a lot else we can do. So let's go back to this one example. This is the query we've been running with this entire time. Day on our x-axis, sum of price and sum of quantity are the three expressions within this query that we're going to need to push down to the database, whereas running sum and the names and values portions we can pull up to the processor. So this is actually what's going to get pushed down to the database in this case. We're going to actually use the database to do all the heavy lifting. So even if this is a billion-row data set, the database is going to handle most of that. It's just going to give us back 1 row per day with these aggregate fields here. Now you might be asking, where is this from? Orders coming by. We're not going to cover this today, but this table name comes from a data model, which lets the processor know about the underlying schema, things like tables, things like columns, and whatnot. We'll save that for another conference, or you can come see me after during office hours and we can talk about it. So we're going to get through the rest of this pretty quick. This is what the database hands back. Pretty standard. This is what you'd expect the database to hand back. From there, we take that result and we evaluate our analytic expressions. So if you remember in our query, we had a running sum. We're going to take that. We're actually going to calculate the running sum down the data set. So this gives us 15 and 20 here. We extend the data set with an additional column. We have names and values. So we use what's called a fold transform in Vega to kind of unpivot the results. This does two things. This adds a names and values column, which is the thing we want at the end of the day. And it also, if you can imagine a pivot query in SQL where you do a case statement and add columns, kind of swing the data out, a fold does the opposite. It actually looks at the columns and folds the data back out and expands the number of rows. This is kind of a tricky transformation to kind of understand, but that's exactly the reason that switch exists, because you can just specify name and values and we'll understand it for you. So after that, you can see we've added some extra fields that our query didn't actually ask for. So the very last step's pretty simple. We just slice out everything we don't want, everything the user didn't ask for. That gives us this final result. This is names, values, and day of date. This is exactly the series that our visualization was asking us for. We take that result, we return it to the app. Our app charts our beautiful query, which we can see here. So this is the before and after, what you send in, and the data you get back out. So all of those steps in the middle, we didn't have to write. We just let the processor do it for us. And it makes it a lot faster and a lot simpler. And that's how the tables turn. This is a good one. I didn't make that up. I wish I did. So the strategy pays big dividends. So the biggest value here is that not having to move our data around to the client, to the mobile device, to wherever it's actually being used, and instead pushing processing toward the data, lets us effectively use at least 1,000 times more data, conservatively, right? So where does that bring us? So we have a familiar Excel-like formula language. Lets us explore data in different ways without new ETL pipelines or app code. That's 100x, all right? That's my claim, 100x. We have a visual query language that lets us ask for the data we need in a way that matches the visualizations we're trying to deliver to our users, 10x. We have data processors that let us deploy our visualization queries directly on top of the high-performance databases that we already have deployed in our organizations, 1,000x. All right, last thinking emoji, that's 1,000,000x. That's a lot of improvement, okay? So I can't guarantee that you're gonna make 1,000,000x more money by adopting the framework, but I can tell you that it is a game changer for data teams that build these applications and the decisions makers that have to use these applications to make critical decisions every day. And so with that, I want to talk about where we're going to go from here. This is the roadmap slide. So we're actually going to release the core part of this framework under an open source license. We're going to expand the built-in function library. We're going to build out more real-world examples. So this talk was kind of abstract. We want to give concrete examples of ways in which this can be used and applications where it's valuable. We're going to expand our database adapter library. Like I said, portability is a really critical part of the design of the system, and we want to make good on that. We want to integrate with open tools like dbt. So we didn't get to talk about the modeling layer today, but the modeling layer is really powerful and connects throughout the entire system. We use dbt at Mode. We really like it, and so we think there's a chance for those two things to join together. We want to integrate on the other side with tools like Vega Lite that have powerful visualization tools that can actually leverage the query language and the processors that we've designed. And at the final layer, at the very top, we want to build common components for frameworks like Angular, React, Native, et cetera, right? So we want to basically integrate the entire stack, top to bottom, for building these data applications. So how do I get involved? Well, this is the way to do it. We have a switch data org on GitHub. We have a community repo, so you can head on over there, hit the star button. That's definitely what you want to do. We're going to post links. There's already some resources in there. This talk is in there. There's going to be a Slack chat. Even if you're not going to use the framework right away, maybe we'll have a data engineering support group in there. We can talk with one another. And what I would ask is, how can I help you? So if you know teams that you think this might be valuable in, if you have meetups, if you just want to talk to me after this talk, I want to know about all these things. So I know that was a whirlwind of an overview, but thank you again. And it's Q&A.
Hey, so one question about like the result that gets sent back. Are you limiting it? I'm sorry if you already mentioned this, but are you limiting it to like aggregation stuff? Because if you have a database with millions of rows and you do like that column plus one and try to send all the data back, things are going to be bad.
Yeah, so there are two kinds of queries that we use the system in at Mode today. One is just like a paginated, like select star pagination type query, which we didn't go over here. But yeah, pivot queries are always designed to be aggregated. So pivot queries are designed for aggregation and grouping. They don't do formulas kind of across the entire data set. We do have a flat query that we also use kind of separately from this that we can do that stuff on, but when we do, we make sure to be careful to make sure it's paginated so that we're not sending like the entire database. Like, that's not really feasible. So yeah. That's how we handle that situation.
Gotcha, cool, thanks.
Yeah.
Thank you. So I missed the beginning of the talk, so if the answer wasn't there, sorry to everyone, latecomer. But one challenge we have is typically translating some of this higher level construct into like different dialect of SQL. And I'm wondering if that's part of the scope of this framework. One common area that's like a common gotcha is like the different date functions for different databases. Are slightly different. So are you guys providing kind of a translation layer there?
Yeah, so we didn't go over that, but when the planner decides to push down queries, what it's actually doing is it's actually building a relational algebra data structure along the way, and then that relational algebra actually gets passed to a SQL adapter. So yeah, we use this exact case at Mode today, where we have different backends with different date functions, and so because we have the SQL algebra tree, we can actually just traverse the tree and make decisions along that traversal about which functions to use, how to quote things. We can do things like take limit and top. If you've ever used SQL Server, it uses top instead of limit. All of those things, we actually give you direct access to the relational algebra tree, so you can optimize and rearrange things and make decisions about how to spit that out. That is part of the adapter framework, and part of expanding the adapter library here will be building those SQL generators that take that relational algebra and generate the correct SQL. That's one of the tasks that we want to sort of expand out.
What's the language being used for this?
TypeScript. Everything's in TypeScript, yeah.
Hi, I just had a question on in your opinion, what's the ideal customer or like the end user for this framework? Because for example, I can see, for example, less technical users could potentially use this kind of query grammar language with formulas, but then it might take some ramp up for them.
Yeah.
But I can also see more technical users, they might not like all the abstractions that you're doing. So then, yeah, I'm just trying to figure that out.
Yeah, so it's different layers. So the formula language is obviously for business users. It's kind of designed to be a common language between the business users, the people writing the data applications, the analysts. The query language itself, which I think you mentioned, today it's really, really targeted at being built programmatically. So we have a drag and drop visualization editor. We have other visualization tools as well that use this, but that language is specifically targeted to be generated by computers today through a user interface. So it's not so much like Vega in the sense that Vega is intended to kind of be built by developers directly, by hand. Our system is built to be programmatically generated. Does that answer your question?
I guess I'm also curious, within Mode, have you guys had any non-technical users try to use this framework, and what was kind of their experience?
I see. So in terms of building applications with it, it's been within our product engineering team today. We are exposing the query language to our users right? So we build a tool that lets users build reports in our system. The query language itself will be exposed through a simpler interface, I think, a little more targeted at various use cases, along with this very kind of complete visual kind of query interface. But we are currently working on the best interface for folks like data analysts who do want to do this, some custom visualization, but might not be as technical or know as much about the grammar of graphics right off the bat. Does that make sense?
Yeah.
We plan to build APIs kind of along the way, targeted at different users, sort of the technical data engineers all the way up to the sort of non-technical data analysts who are all trying to get some of this work done.
Thank you.
What kind of access do you have for like performance tuning? Like if your query is running slow, it may be a problem with the indices. You might have to change your indices, change your query. It's always something.
Yeah, so the way that the system as it's designed, let's talk about the processor system. It's designed to be embedded within kind of an outer shell that's actually doing more of that stuff. So at Mode, we have a sort of a backend service that we host the processors inside of, and we leave it to that backend service to kind of understand if things are being slow or not. So the processor will actually send its queries through this service, and we delegate that kind of stuff to the service. The processor is kind of unaware, so to speak, of the actual physical underpinnings of the database. So there's no layer in Switch today for thinking about optimization, if that makes sense. So all the Switch processor knows about is how to generate SQL queries and send them off to the database. It doesn't actually understand how the database will process those things. There is opportunities to build additional information in and kind of build optimizers into that layer, but that's probably a further out thing. Optimizers are a lot harder to build. As you can probably talk to the Calcite people and some of the other folks. Those things are kind of harder to build. So yeah, we delegate that to another layer in our system. And we kind of attach them together in our logging system. So we make sure that the processor sends log info to kind of the same place that the outer kind of host system sends it, and we correlate that later, and we're starting to look at information about that to make sure that we're not generating bad SQL out of our SQL generator and things like that.
Follow-up question. So is there an implementation or an endpoint that is exposed at Mode that I can hit, that kind of sending my payload or my query to get these results back? Soon.
Yeah, so all of Mode's kind of data layer will kind of be augmented with APIs focused around this stuff, right? So one of our goals is to build our platform on top of these open protocols and these open standards and sort of build a community around that.
Yeah, to follow up on that question, I've used Mode, and the starting point is always a SQL query. Mm-hmm. Is there anything to that? It seems like a pretty big change where you become aware of the data model, and I can request it from a higher level of abstraction. Is there anything today available to the public for users, or is this something internal?
Not in the sense of like a data model that lives in like a file system that you access. But if you use Mode today, you're already kind of using data models. You might not know that you are, but if you look at our visualization system and you see that the pills that you have to drag and drop in our visualization editor, that's kind of implicitly a data model behind the scenes. And that's kind of the extent to which we use the term data modeling as it applies to this system. So you can talk to Mode people about the Mode roadmap.
Okay.
Yeah. It's only a half answer, but as far as Switch is concerned, that's like one way to think about the data model.